Welcome student. In this section we'll study about uniform motion and non-uniform motion. You have studied about distance, displacement. When an object covers equal distance in equal time interval, it is said to have uniform motion. From this table you can easily observe that the object A is having uniform motion and the object B is having non-uniform motion. At 9:30 am it covers 10 meter, at 9:45 20 meter, 10 am 30, means every 15 minutes the object is covering 10 meter distance. But the object B 9:30 12 meter, 9:45 19 meter distance, at 10 am it is at 23 meter distance. So the equal distances in equal time interval is not covered. Such type of motion is called as the non-uniform motion. So what is uniform motion? When an object covers equal distance in equal time interval. And non-uniform motion when object covers unequal distance in unequal time interval. Uniform and non-uniform motion can also be expressed graphically. This is the graphical representation of the uniform and non-uniform motion. In this graph you see that as the time is increasing, the distance covered by the object is also increasing uniformly, means it covers equal distance in equal. Such type of motion is called as uniform motion. Here non-uniform motion, why? The distance covered non-uniformly, unequal distance in unequal interval of time. Such type of motion is called as the non-uniform motion. So while representing graphically, along x-axis you have to take time, along y-axis you have to take distance covered, because time is independent value, it is taken along x-axis. Distance is dependent upon time, so it will be taken on y-axis. Some more illustrative examples are given to understand what is uniform and non-uniform motion, what is the cause of uniform and non-uniform motion. Here you see the distance between city A to city B is 90 kilometer, and the car first half an hour it covers 30 kilometer, next half an hour 30 kilometer, next half an hour 30 kilometer, means in equal time interval it is covering equal distance. So what type of motion it is having? Uniform motion. Next is non-uniform motion. Again the distance is same between city A and city B, 90 kilometer, but this car 1 hour 30 kilometer, another next 30 kilometer in half an hour, next 30 kilometer in 0.25 hour. So equal distance is not covered in equal time interval. Such type of motion is called as non-uniform motion. From this you can also observe what is the cause of non-uniform motion. If the speed here, how fast the car is moving, which is moving faster, this car is moving faster, so the speed of the body is constant, it is moving at the same rate, 60 kilometer per hour, 60 kilometer per hour, 60 kilometer. You have in lower classes you have studied how to calculate speed. Speed is equal to distance upon time taken. So here the stop 1, stop 2, the car is moving at the same rate. So this is the cause of uniform motion. What are the example of uniform motion? Revolution of earth around the sun, it takes 365 days, each year 365 days. Revolution of moon around the earth, rotation of earth on its axis, movement of hands of a clock, motion of pendulum of clock, motion of the fan, rotation of the fan, all these are the example of uniform motion. What is the cause of non-uniform motion? If the speed of the body is not remaining constant, here from city A to stop 1 the speed is 30 km per hour, from stop 1 to stop 2 speed is 60 km per hour, stop 2 to stop 3 120 km per hour. So speed is not constant, and that's why the car is having non-uniform motion. the motion of the car on straight road, whenever we are moving, jogging, running, athletes, they don't have uniform motion, non-uniform motion. So the motion can be described by a quantity, physical quantity, which is the rate of the motion. In order to explain which object is moving fast, which is moving slow, we use a physical quantity called as the speed. We use a physical quantity called as the speed. So what is speed? It is the rate of motion. Some object move fast, some object may be slow. Different object move at same rate. It may happen that there are different objects, they are moving at the same rate. This rate of motion is called as speed. One of the way to describe this rate of motion, how can you calculate the rate of motion? By calculating total distance covered by the object in unit time. Who is moving fast? How will you compare? By finding out its speed. How can you calculate distance covered upon time taken? What is its SI unit? The unit of distance is meter, the unit of time is second, so meter per second. Again, it requires only magnitude. That's why it is scalar quantity. A car moving on a straight road with a speed of 40 km per hour, only magnitude. No direction is specified. So such quantity is called as scalar quantity. If the bigger unit may be expressed, that is the speed of the train may be expressed, it is expressed in kilometer per hour. An object may not have constant speed all the time it is moving. A car is moving on the road. It may not have constant speed. When there is traffic signal, it will wait. So speed changes. When there is a lot of traffic on the road, the speed changes. So even the car moving on the road may not have constant speed. Its speed may change time to time. It means the motion is non-uniform. So therefore, we describe the rate of motion in terms of average speed. For example, you are going to Delhi, you reach Delhi from your home after 9 hours of journey. It doesn't mean that throughout 9 hours you are in motion. Again, if there is traffic, you have to wait. Traffic signals, you have to wait. So what we are talking, the car is moving with a speed of 90 km per hour. We're talking of average speed because it may not be moving with constant speed. So average speed, how can you calculate average speed? It is equal to total distance covered by total time taken. One example you can take, like an object travels 16 meter in 4 seconds. First 16 meter in 4 seconds, then another 16 meter in 2 seconds. What is the average speed? You will find out the total distance traveled by the object. It will be 16 plus 16, that is 32. Total time taken 4 plus 2, that is 6 seconds. So average speed will be total distance upon total time, 32 by 6, that is 5.33 meter per second. Next is another quantity which is more comprehensive, which is more accurate to express the rate of motion, that is velocity. The rate of motion can be more comprehensive if we specify its direction. The car is moving on the road towards north along with its speed, with a speed of 100 km per hour. So that is, we are talking of velocity. So what is velocity? It specifies both magnitude as well as direction. So this velocity is a vector quantity. How can we define velocity? It is the speed of an object along a specific direction. When the object is moving on a straight line, linear motion, the speed and the velocity is same. Velocity of an object may be constant in straight line when moving with constant speed. Velocity can never be, speed can never be zero. As long as the object is moving, speed cannot be zero, but velocity can be zero. Velocity becomes variable on changing the speed. How can we change the velocity? Either by changing the speed. First the car is moving with 40 km per hour speed, then it moves with 60 km per hour, changing speed. So that is, velocity is changing. If it changes direction along a circular path, it has to change the direction. Speed may be same but direction is changing, so velocity changes, or by both speed as well as direction the velocity can be variable. So variable velocity, constant velocity, average velocity. What is average velocity? When the object is moving in a straight line, average velocity is calculated as we calculate the average speed, that is displacement, that is the distance covered in a particular direction upon time taken. If it changes velocity at uniform rate, then how the average velocity can be calculated? It is calculated by this formula using u plus v upon 2. What is u? U is the initial velocity, v is the final velocity. Speed and velocity both are having same unit, that is meter per second. Next, what is the difference between speed and velocity? What is speed? Speed of a body is the distance traveled by the body in per unit time. Velocity, distance traveled by the body per unit time in a given direction, in a specified direction, that it may be said as speed along a given direction. Speed is a scalar quantity, vector quantity, velocity is a vector quantity. Speed cannot be zero. I already said earlier that as long as the object is moving, speed cannot be zero, but velocity can be zero. How it can be zero? You are throwing a ball upward. After reaching maximum height, what do you observe? It falls down. After certain height, after attaining certain height, it falls down. When it falls, when the velocity becomes zero, when you are throwing, the velocity goes on decreasing and it becomes zero. As soon as the velocity becomes zero, it starts falling due to acceleration due to gravity. The velocity can be zero. Now types of speed and velocity. Average speed, you know, it is total distance by total time taken. Instantaneous speed, speed during a very small interval of time. At 12 o'clock the car is at 40 km/h speed, so it is instantaneous speed. Average velocity, that is the net displacement upon total time taken. Instant velocity, velocity during a very small interval of time. Speed and velocity can be understood by this example also. This motor driver concerns speed only. It is moving on the straight line. जहाँ जहाँ track है वो move करेगा with the speed of 90 km/h. But pilots of the aircraft concern about velocity, direction as well as the speed, direction of the wind, speed of the wind. So its speed is denoted by velocity. So speed is a single measurement that tells how fast you are going, and velocity, you know both your speed as well as direction. Now a few in-text questions related to speed and velocity. Cite an example of motion where speed of an object is constant but the velocity is changing. That is rotation of fan, planets. Why? Because the direction is changing. Under what conditions the magnitude of average velocity of an object equal to its average speed? When the object is having straight line motion. What does the path of an object look like when it is in uniform motion? Path is straight line. We have drawn the graph also to represent uniform motion. It is straight line graph. During an experiment, a signal of spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? This distance you have to calculate, and the signal travels at the speed of light. This is given 3 into 10 raised to power 8 meter per second. So you know distance, how can you calculate? It is equal to speed into time. So speed is 3 into 10 raised to power 8 into time. Time is given in minutes, you have to convert it into second. So 5 into second, that is 900 into 10 raised to power 8 meter. Next, another physical quantity which is used to describe the motion is acceleration. Now in this part you will study what is acceleration. During uniform motion of an object along a straight line, If the object is moving along a straight line, a car is moving along a straight line with a speed of 60 km per hour, the velocity is constant with time. In this case, there is no change in velocity, that is, it is zero in case of uniform. But in case of non-uniform motion, velocity varies with time. It has different values at different instant of time. It may have different points of path also different. So more precisely, this change in velocity of the object during any time interval can be expressed in terms of acceleration. So what is acceleration? Rate of change of velocity with respect to time. The acceleration may increase when you are applying accelerator. You are driving a car, the velocity increases. On applying brakes, the velocity decreases. That velocity, decreasing velocity, acceleration is changing. That is called as retardation or deceleration or negative acceleration. So acceleration, rate of change of velocity with respect to time. It is a vector quantity because it requires both magnitude as well as direction. Acceleration is related to change in velocity, and the velocity in terms of magnitude or direction. So both this are regarded as accelerated motion. Here you can see circular motion. The planets are revolving, the motion of the planet, motion of the fan. At each point, the direction of the velocity is tangent drawn at that point. Take a stone, tie it with a thread and move it very fast in this circular path and throw the thread at any point. You will find that it is moving out. पत्थर कभी भी अंदर नहीं गिरेगा, बाहर. It means what is the direction of velocity here? Outward. Which force is keeping it in circular path? Force of attraction, gravitation. Followed? So attractive forces. So in this circular path, at each point the velocity is changing as it is changing the direction. So such type of motion is called as accelerated motion. At same rate the velocity is changing, it means it is uniform accelerated motion. Now what is acceleration? Mathematically, how can you find out acceleration? It is rate of change in velocity. Rate means divided by time, that is change in velocity upon time. So change in velocity is given by v minus u. V is the final velocity minus initial velocity upon time. Acceleration may be 0. When the acceleration is 0, when v is equal to u, there is no change in velocity, acceleration is 0. When it is positive, you are applying accelerator, velocity of the car increases, so that is positive acceleration. Negative, on applying brakes, the car stops, that is negative acceleration. SI unit of acceleration is meter per second square. How change in velocity? Meter per second times second. So altogether what will be its SI unit? Derived SI unit, meter per second square. Next few questions regarding uniform and non-uniform acceleration. This activity is given in your NCERT textbook. In everyday life, you come across a range of motion in which acceleration is in the direction of motion, acceleration against the direction of motion, acceleration is uniform, acceleration is non-uniform. Can you identify one example of each above on the type of motion? First is acceleration in the direction of motion. A freely falling object. Object is moving, for velocity, motion is downward, and acceleration due to gravity is also downward, free fall. Acceleration is again the direction of motion. You are throwing a stone upward. What is the direction of motion? This way. In which direction the acceleration due to gravity is? It is pulling back downward. Or during application of the brakes in your car, what happens? The car is moving forward. On applying brakes, velocity changes. This is again the direction of the motion. Acceleration is uniform. Freely falling body fall, When you are throwing an object, the velocity goes on decreasing. Maximum height, the velocity becomes 0, and then it falls freely due to acceleration, due to gravity. This is acceleration is uniform. Circular motion, acceleration is uniform. Circular motion means the planetary motion, rotation of the fan. Acceleration is uniform. Non-uniform, when the motion of a car on straight road, heavy traffic signal, the velocity changes, means the motion is not uniform. Another in-text question: a bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. So first of all, during solving the numerical, write the values which are given, which initial velocity is 80 km per hour, final velocity is 60. So, and time is 5 seconds. So 5 km per hour and second uniformity nahi hai. You have to convert it into meter per second. So kilometer per hour, when it is converted into meters per second, you can multiply with 5 by 18. कहाँ से आया? 1 kilometer is equal to 1000 meter and hour 3600 second. So you get this value of u and v. A is equal to v minus u by t. Time is given in second, so directly you can put this value and you get this value for acceleration. Negative sign. What does this negative sign indicate? That the velocity is decreasing, retardation is taking place. Next question: a train starting from a railway station moving with uniform acceleration attain a speed of 40 km per hour in 10 minutes. Find its acceleration. Train starting from railway station means u is given. Initial velocity is 0. It attains a speed of 40 km. So v is 40 km per hour. Time 10 minutes. So you have to convert it into second, and 40 km into meter per second. 40 into 5 by 18, you will get this value. Put it this in this formula: A is equal to v minus u by t. You will get this value 0.018 meter per second square is the acceleration. Here acceleration, the value is positive, and from this numerical also you can see question that the velocity speed is increasing from 0 to 40. So A comes out to be positive. Here 80 to 60, so the value of A will be negative. So acceleration can be 0, positive or negative. So that's all for today. Thank you. If you have any doubt in this section, you can write your queries in comment section. You will also get objective type question in Google form in my description box. Try those for self-assessment. Thank you.